There are moments in the history of exploration when a single journey completely changes how we see the unknown. For centuries, maps of Earth contained blank spaces labeled with guesses and myths. Only when explorers reached those distant places did the real picture emerge. The same thing has happened in space exploration, and few missions demonstrate it better than New Horizons. When NASA launched New Horizons in 2006, its destination was Pluto, a tiny and mysterious world orbiting at the edge of the known solar system. At the time, Pluto was one of the least understood planetary bodies ever discovered. Although astronomers had known about it since 1930, it remained little more than a blurry point of light even through powerful telescopes. Scientists could estimate its size and identify some broad surface features, but nobody truly knew what Pluto looked like. Was it a frozen and lifeless world? Was it geologically active? Did it have an atmosphere? These questions remained unanswered for decades. New Horizons was designed to change that. The spacecraft launched on one of the fastest planetary missions ever attempted. Moving at incredible speed, it passed the Moon in less than a day and later received a gravity assist from Jupiter, using the giant planet's gravity to increase its velocity. Even at those tremendous speeds, reaching Pluto still required a journey of nearly 9.5 years. For much of that time, New Horizons traveled through deep space in near silence. Millions of kilometers from Earth, it spent long periods in hibernation mode while engineers monitored its health and prepared for the historic encounter ahead. Then, in 2015, the world finally got its first close look at Pluto. As the spacecraft approached, images became clearer week by week. What had once been an indistinct dot gradually revealed patterns, colors, and terrain unlike anything scientists expected. Excitement grew rapidly throughout the scientific community as Pluto began to show signs of being far more complex than anyone had imagined. One feature immediately captured global attention: a giant bright region shaped roughly like a heart. This area, later named Sputnik Planitia, became one of the most iconic landscapes ever discovered in the solar system. Stretching hundreds of kilometers across Pluto's surface, it appeared surprisingly smooth and remarkably free of impact craters. That observation alone was astonishing. In planetary science, impact craters act like timestamps. Older surfaces accumulate more craters over time, while younger surfaces are continually renewed by geological activity. The lack of craters within Sputnik Planitia suggested that Pluto was not a dead world. Instead, something was actively reshaping its surface. Scientists soon discovered that this region consists largely of frozen nitrogen ice. Unlike water ice, which behaves like solid rock in Pluto's extreme cold, nitrogen ice can slowly flow and move across the landscape. Some researchers believe the ice within Sputnik Planitia is constantly circulating through a process similar to convection, where material rises and sinks over long periods of time. In other words, Pluto's surface may still be changing today. The surprises did not stop there. New Horizons revealed enormous mountain ranges rising several kilometers above the surrounding terrain. These mountains are composed primarily of water ice, which becomes incredibly hard at Pluto's temperatures. Instead of acting like snow or ice on Earth, water ice on Pluto functions more like bedrock. The spacecraft also discovered vast valleys, cliffs, and unusual formations that hinted at a complicated geological history. Some features may even be linked to cryovolcanism, a process where extremely cold materials such as water, ammonia, or methane erupt instead of molten rock. These discoveries transformed Pluto from a simple frozen object into a dynamic world with a rich and fascinating past. Another major revelation came from Pluto's atmosphere. Before the mission, scientists knew Pluto possessed a thin atmosphere, but nobody expected it to be so beautiful or complex. New Horizons observed multiple layers of atmospheric haze extending high above the surface. When sunlight passed through these layers, Pluto appeared surrounded by a glowing blue halo. The images were breathtaking and instantly became some of the most memorable photographs ever taken in deep space. The atmosphere itself is constantly changing as Pluto travels along its elongated orbit around the Sun. Frozen gases on the surface can evaporate and later refreeze, creating seasonal cycles unlike anything found on Earth. For a world once dismissed as a frozen leftover, Pluto proved remarkably active. Yet Pluto was only part of the story. The mission also delivered humanity's best view of Charon, Pluto's largest moon. Charon is unusual because it is extraordinarily large compared to Pluto. The two worlds are so similar in size that they orbit a common center of gravity located outside Pluto itself. Some scientists even describe them as a double-world system rather than a traditional planet and moon arrangement. Charon's surface looked dramatically different from Pluto's. It contained enormous canyons, fractured terrain, and regions shaped by a completely separate geological history. One of its most distinctive features was a reddish-colored polar region. Researchers believe this unusual coloration forms when gases escaping from Pluto become trapped on Charon's surface. Over time, solar radiation transforms these materials into darker organic compounds, effectively allowing Pluto to leave its mark on its companion world. The idea that one world could slowly paint another across the vacuum of space sounds almost like science fiction, yet New Horizons provided evidence that this process is real. After completing its historic flyby, New Horizons continued deeper into unexplored territory. Many missions end after reaching their primary target, but New Horizons still had enough fuel and capability to investigate another object far beyond Pluto. That target became Arrokoth, a small Kuiper belt object located billions of kilometers from Earth. Arrokoth was discovered years after New Horizons had already launched. This means the spacecraft eventually visited a destination that humanity did not even know existed when the mission began. When the first close-up images arrived, scientists were stunned. Instead of resembling a typical asteroid, Arrokoth appeared as two flattened lobes gently connected together. This shape identified it as a contact binary, meaning it formed when two separate objects slowly merged billions of years ago. Unlike many bodies in the inner solar system that have experienced countless violent collisions, Arrokoth appears relatively untouched. Its surface preserves clues from the earliest stages of planetary formation. Scientists believe it may represent one of the most pristine objects ever studied up close. In many ways, observing Arrokoth was like opening a time capsule from the birth of the solar system itself. Its reddish coloration and unusual chemical signatures suggest the presence of complex organic materials. Some compounds detected on its surface remain difficult to fully identify, highlighting how much we still have to learn about the distant outer solar system. The discoveries at Pluto and Arrokoth carried an important message. Again and again, New Horizons showed that our assumptions about distant worlds can be completely wrong. Pluto was expected to be relatively inactive, yet it revealed evidence of ongoing geological processes. Charon turned out to be one of the most unusual moon systems ever observed. Arrokoth demonstrated that even tiny objects can preserve invaluable information about the origins of planets. These encounters remind us that exploration matters because distant observations can only reveal so much. Telescopes provide hints, but true understanding often arrives only when a spacecraft reaches its destination. Today, countless objects remain undiscovered or unexplored beyond Neptune. Many may contain hidden oceans, unusual chemistry, or geological processes unlike anything seen elsewhere in the solar system. The legacy of New Horizons is therefore much larger than the worlds it visited. It expanded humanity's understanding of what is possible. It revealed that the outer solar system is not a frozen wasteland filled with lifeless debris. Instead, it is a region rich with complexity, history, and scientific wonder. Most importantly, New Horizons reminded us of a simple truth. Every time humanity reaches a new frontier, reality turns out to be far more fascinating than imagination. And somewhere beyond the worlds we have already explored, countless more discoveries are waiting for the day we finally arrive.